Welcome everyone. Hopefully you're in the right place. We're going to be talking about building cloud-powered iOS apps with Azure. We've got a lot to go through, so I'm going to kind of breeze through some of this really quickly. My name is Risner. I'm a technical evangelist at Microsoft. So on top of doing software development and working with customers and all sorts of stuff, I also come out and do presentations like this. I did about six years of .NET development before I made a pretty hard switch over to doing native Android and iOS development, and I've kind of gone from there a little bit back and forth now. So today we're going to start by talking about why the cloud, why it's important. Who in here would say they've got a great understanding of what the cloud is? Awesome. He's going to give the rest of the presentation.
Okay.
So we're going to talk a little bit about why the cloud, why it's important you want to use it as opposed to a server set up in your closet. We'll talk about kind of what Azure is, what some of the services are, and how it works. We'll talk specifically about how we can build iOS apps with Azure and see a bunch of good demos. I'll briefly cover some additional services that are valuable to iOS devs, and then we'll have time for questions at the end. So first we'll address why we talk about the cloud, why you want to use it as an iOS developer. Well, prior to kind of the cloud being a thing, really what you had were there were data centers where you could run servers in, or you could perhaps put a server up if you had your own data center, or you could just run a server in your house and find some way to make an endpoint to it. With the advent of the cloud, though, you don't have to figure out, hey, where can I get a server from at a local data center, or how do I stand up my own machines, or how do I do any of this? The idea is that we make it easy for you so that we take care of kind of all the infrastructure, and then you just focus on building an application. And there's different tiers of that. Kind of the thing that most people think of when they think of the cloud is Amazon EC2, and that's virtual machines, right? And Azure has virtual machines as well, and all the cloud providers have virtual machines. And those are really great things, and a lot of really amazing products are built on top of those. But if you're an app developer, using a virtual machine and building out your backend for your mobile application on top of that, that's actually a lot of work, because there's a lot of infrastructure you still have to do on top of virtual machines. So we look at on top of that is abstractions away from just virtual machines. So it's kind of services on top of that make it easier for you to build applications. And that's what we're going to look at today. And kind of when we talk about the cloud, there's three kind of good primary reasons why we talk about using the cloud. It's speed, scale, and economics. So if you think about speed, instead of having to worry about buying a server, provisioning it, getting it set up, all you have to do is go to a cloud and click a couple of buttons, and you instantly have a backend or a server or Linux virtual machine or whatever you want to have. So it's way faster than if you had to do all that stuff yourself. As far as scale goes, when I'm building out my little test application today, I'm only one hitting it. Maybe I give to a few friends, and I've got maybe 10 people using the application. I don't really need a very strong backend or a strong virtual machine running my application. I just need something simple. But if tomorrow it gets very, very popular, I don't want to have to redesign my backend. I just want to say scale up. That's one of the beauties of the cloud, is that you can do that. You can just drag a little slider over and say, now I want 100 machines running my application. And the last is kind of feeds into that is economics. All this is about saving you money. You're not paying for hardware. You're not paying for stuff you're not using. You're not paying for stuff that's just sitting there and not being used at the end of the day. You're only paying for exactly what you use. And we talk about Azure. Azure has a very huge global scale. At this point, I think it's the largest footprint of all the public clouds in the world. And right now, there are 34 different data centers and regions around the world, and we'll deploy most of our stuff to one in central US today, but they're all over the world, and you actually have the ability to kind of load balance things across. So you're not just reliant on stuff in one region or one data center. Now this graphic, which unless you have good eyes, you can't read pretty much anything on it. This is kind of some of the features that Azure has inside it. If I were to spend maybe one minute on everything that Azure has, each individual feature that Azure has, we need more than the time we have today, so we can do that. So what we're really focusing on is what can you as an iOS developer use to kind of make a better application. And we're primarily going to focus on this block at the top, which is called Azure App Service. So Azure App Service is kind of a container that allows you to host what are essentially web applications. But there's a couple different kind of flavors or capabilities there. There's kind of 4 different kind of apps here, but we're really going to talk about the top 2, and really mostly the top one on the right. So as I said, App Service is kind of a container, and on top of that you can put web applications. So web apps would be anything you might write in Node or ASP.NET or Python or Java or PHP, etc. If you had a web application you're running today on Apache, in theory you can lift that up, put that on top of Azure in a web app, and it's just going to run perfectly the same way. It's not some weird thing. Now, for web apps, it is running inside of iOS, but that still does have support for all those languages. What we're really interested in, though, is in mobile apps. And mobile app is essentially a set of services built on top of web apps that provide you with capabilities that, as a mobile developer, you really want to use, but without having to worry about how do I write all of this myself. So specifically, the features, the capabilities you get out of mobile apps is stuff like easy data storage. So by default, we're going to be storing data in Azure SQL database. We have the capability to talk to other storage systems as well. User authentication and authorization, so knowing who your users are, what data should they have access to, and more importantly, what data should they not have access to. Back-end logic, so we're not just talking about dumb data storage, just simple CRUD. The ability to craft your own logic for when you insert data, for example, or when you read data, et cetera, et cetera. We're going to do all of that today. Push notifications, so I assume most of us have all integrated with APNS before. How many people have actually built the back-end to actually trigger push notifications and talk to APNS? How many people had fun doing it? Yes, okay, so we've got a system in there that's going to basically save you from doing that, as well as if you want to push to any other mobile system as well. And then lastly, the ability to run back-end jobs, so whether it's daily data processing, triggering daily push notifications, doing image manipulation on data, whatever you might need to do. So now more specifically here, it's kind of the same slide, but just kind of more drilled down. So on the left side, you've got all of the SDKs that make it easy to talk to your Azure mobile app. And so there's native SDKs for iOS and Android and Windows. There's also the Xamarin and the phone gap sort of stuff. On the right side, though, is all the features you get out of it. So I already mentioned the data storage and how you can talk to different data providers. User authentication, all the things you expected here, so Facebook, Twitter, Microsoft, and Google. The one on the end there is Azure Active Directory, which if you work at a company that uses Active Directory, which most of the Fortune 500 do, Azure Active Directory makes it really easy for you to build mobile applications which require your employees basically authenticate against those same credentials, which is a pretty cool thing to be able to do. And then like I mentioned, push notifications down at the bottom. Now at the top left, I'm going to talk about this briefly, but we won't dive too much into the code. But just as part of the client SDK for mobile applications, you get people to do offline data sync. So today when I'm building out my iOS application, it's actually going to be storing the data locally and pushing it up to the server. I'm not going to demonstrate how to make a conflict today, but if you had multiple people using the same application running against the same data, it's going to handle a conflict resolution for you. So say back to the client application, hey, there was an issue. How do you want to resolve this? That's all built into this. So let's go ahead and get started and see how we can create a mobile app. So right here, this is the Azure Portal. This is where you go to kind of do anything you want to do in Azure. There's also a rich command line experience you can use from Bash. It's a cross-platform command line that you can do a lot of stuff, but it's a little bit easier for us to understand how things work by going through the portal. So I'll try and zoom in so you can see this a little better. So I've already created a mobile app, but I'm going to go through the process of creating a new one so you can see what it looks like. So in here, I'm going to go to New. I'll choose Web and Mobile. Then I'll choose Mobile app right here. Now what I have to do is give my mobile app a name, so we'll call this My Mobile App 360. So we'll just name it that, and then I choose what subscription I want to put it in. So subscription is kind of like an account, if you will, for Azure. It's what you'd put all your resources in. Now underneath that, I create this concept of a resource group. And a resource group is kind of a logical container for all of your resources. So let's say for this mobile application, I was going to have an Azure mobile app and maybe an extra database and some other systems as well. Like maybe I need a virtual machine to do some work as well. I can put these all inside a resource group, and then I can logically look at this as one application. So I'll just use an existing one that I've already created. 360 IDEV. Then the last part here is to choose an app service plan and location. This is where it gets into where do you actually want to host your application. So inside here I can choose, of several, bunch of different places. As I mentioned before, I already put stuff into Central US, which is probably the closest data center to here. So that's the closest region rather to here. So I would just choose that. The next step though is now this is where you choose kind of what you want to pay or what kind of features or services you want to use. And there's 3 different tiers. There's premium, standard, and basic. But what's nice is we can go down here and we can just say we want a free tier. So everything I show you today, you don't have to pay anything to sign up, to play around with it, to develop with it. It's completely free. Later on, if you were going into production, that's a potentially different story. But we can choose free, and we can host our application here, and we create a new one name here. We'll just say that. And after I create this, it's going to go ahead and create all those resources for me behind the scenes and set everything up. As I mentioned, I already did this because I don't want to wait too long, because it does take a couple minutes to kind of get everything set up. So I'm going to hop over here to this 360 IDEV mobile app that I already created. Now there's nothing different about this than what the output would be if I created one in the last screen, essentially. Except I've already done a little bit of setup. So the first thing I'll do is go down to the Quick Start tab. This is kind of meant for if you haven't done this before, how do I go ahead and start using this? And what you get is a choice of what client platform you're going to build off of. Now, you don't have to use like one single client app to talk to this backend. So if you're building an iOS app and then later on you want an Android app, you don't create a new mobile app. You just go ahead and come to this exact same screen saying, now I want to do the Android version. So obviously today we're going to choose iOS, and we're going to go ahead and do Swift. Now, the other step that I already did today was I already created a database. If I hadn't done that, though, it would just go in and ask me to name the database, choose where I want to run it. I'd want to run it in Central US, so it's right next to my mobile app as well. We'll give it a second because the Wi-Fi seems to be being fun. We'll just go ahead and switch over to a different Wi-Fi network. Let's try that again. All right, so hopefully that goes a little closer. Okay, so it already says I have my database connection. Great. The next step is to choose what kind of backend you want to have. Do you want a Node.js backend or a C# backend? For right now, we don't care about that. We'll talk more about that when we get to how you do your logic a little bit later. But after that, since we're doing kind of the quick start template application, what we're able to do is we can deploy a pre-built backend, which we'll look at in a minute, and then create a to-do item table. So we're going to have a to-do application today. It's kind of easy, everybody understands it. It's pretty easy for you to go back and walk through this yourself, so it's going to be very simple for you guys. So I've already done that right there. So the last part here is I can choose to create a new app or connect an existing app. If I choose to connect an existing app, it's going to tell me, here's where you get the SDK, here's how you add it to your application, here's how you start using it. I'm going to go ahead and download this new application, which is just a templated app. And because this might take a second or two, I'm just going to go ahead and hop over here where I've already got this. Now, the first thing we're going to do is just go ahead and run our application, and then we'll look through some of the code. So the first thing it's going to do is it's going to go up, it's going to go to the server and say, hey, do you have any to-do item data? I haven't saved anything yet, so there's not going to be any data here. If I do hop back over here, though, and go down to the settings pane, I can go down to Easy Tables, and this is a very easy way for me to access the data and see what's being stored for my mobile application. As I said before, I already created my to-do item table. And if I go in here, we'll see there's no data. There's already some defaulted columns that automatically get generated for a table. Those are used for kind of that conflict resolution and offline sync. But there's no other data here. There's nothing specific to to-do items. So if I go back to my application, let's say we will do a couple things. We'll fly to Denver. We'll learn about iOS. And I'll go ahead and I'll just trigger a sync of that data. Now if I go back and I refresh my data, see I've got these two data rows here. Both those items are up on the server, and it added this text and this complete field over here. At no point did I have to tell my backend this is the data types. One's a text field, one's a boolean. It uses something called dynamic schemization to generate that schema for us, and that's something you can turn on and off. So when you go to production, you don't want to accidentally add new columns. You turn that dynamic schema off. When you're developing, you leave it on. Or you turn it off, and you manage your schema manually if you want to. Now, if we go back here, we can go ahead and say, all right, we did that. Let's mark that as complete. Sync again. And the way this template application is built is that you have to kind of trigger that sync by doing a pull to refresh. There's nothing to say you have to do that. You can just trigger that whenever I do an update or I do an add. It's just the way the app's built right now. If I go refresh the data, we'll see that now that one is marked as complete. So it's doing that updating very easily. Behind the scenes, everything here is happening via REST. But we'll go ahead and look at the SDK, and we'll see we don't have to do we don't have to do our manual HTTP calls from the Swift app, from the Swift code, or anything like that. We use the SDK for it. So if we look at the application, first thing we'll look at is we'll go into the frameworks folder. The code should be quite large. This left side is a little small, so I'll just kind of talk through it. But this right here is the Microsoft Azure Mobile Framework. This is what you would drop in if you had an existing application and wanted to start talking to Azure. If we look up here, as I mentioned before, we're doing offline data storage and synchronization. And it's using SQLite behind the scenes, but it is, of course, using core data here as well, the data model. So inside here, we can see I've got this to-do item. I'm creating this locally, and it's going to get matches up with the server there. If I go into our to-do table view controller, so if we go down, we've got a few different objects we'll look at. First of all, there's an MS sync table. That's basically our table concept. So basically, how do we talk to that to-do item table? and it's a sync table as opposed to an MS table because it's doing offline data sync. Then we have our core data store, that's for doing the actual data storing locally. We're going to skip the fetch controller for just a second, go down to viewDid load. Inside viewDid load, we create our MS client using the URL of our mobile application. If I were to take this URL here and just open it in the browser, we just get an endpoint that says, hey, your mobile app is up and running. So let's go back here. After we do that, we do some setup using the data context and the data store. We set all that stuff up. We initialize our table by passing in the string to-do item with sync table with name. So that's basically what's saying this table object is tied to that to-do table. After that, we just have some kind of boilerplate stuff. If we go up to this refresh method right here, when we want to actually get the data down, we need to tell our backend that we only want to get data that's not completed already. So we create an NS predicate here, and we just say complete is not equal to true. We pass that into a refresh or a pull or a select statement against the server. Behind the scenes, that gets translated to an OData query. That goes up to our mobile app backend, which then translates that to a SQL query for us. At no point in here do I need to know anything about SQL, do I need to know anything about the schema or how it handles things on the server. I just kind of do things as I would do them on the Swift side. And I'm calling into this REST API without having to do any of that HTTP network traffic myself. So if we look down here, when we refresh, we take that query we had before and do pull with query. If we go down a little bit further, we'll see that when we update items right here, we just call update, pass in the item, call update on the table. It's doing basically all that translation behind the scenes for us. And then if we look a little bit further down for adding an item, again, very similar. Where was that? Oh yeah, it's a table item. So right inside here, we create the item to insert right here, and then we just call insert. So there's nothing funny going on. It's a Swift SDK. It's very easy for us to use from our Swift code, and it's pretty simple to get started. So I've already talked a lot about data storage. We'll kind of cover it quickly. So as I mentioned, we're using Azure SQL Database behind the scenes, but you can connect into any data system you want, including connecting to on-premise data storage. So many companies still aren't okay, or for regulatory reasons cannot store their data in a public cloud. What's really great about mobile applications is that you can easily create what's called a hybrid connection, and essentially just point your backend at a database running on-premise wherever you might have it. And it'll give you all the functionality of your mobile app, including the scalability and all the stuff I'll continue to show you today, as well as the easy to use the SDK, all that stuff. But it's storing all of that data in your own data center as opposed to Azure. I already mentioned offline data sync. It does conflict resolution for you. So again, if I was having multiple devices writing the same data, if I had, for example, device A and device B, and they both got the same data, and then device A updates it, and then device B tries to update it without hitting the latest, the server would go back and say, hey, you can't overwrite this data. Somebody else already changed it. What do you want to do? And you as a developer can decide, do I always want to overwrite that data on the server? Do I want to show something to the user? It's up to you. We kind of give you all those tools to kind of make those decisions. So the next section we're going to cover is talk about logic and APIs. Right now, all I have is a dump data store. Everybody in here could run the same application, insert the same data, update the data, but it's just sitting there. Like there's no logic there. Let's get into what backend you choose. When I chose the Node.js backend, essentially what happened was it created a boilerplate Node.js Express site with a little bit of stuff on top of it. And that stuff on top of it is the Azure mobile app server-side SDK. So just like we have a client SDK, there's a server SDK, in this case a Node one. And this gives us this ability, like the easy table stuff we did before. It's also going to give us the capability to make easy APIs, which we'll talk more about in a second. It gives us that dynamic schematization for tables. What we're going to see in a second is that I can actually edit the code for my Node.js application up in the server, or in the browser, and we're going to do that in just a moment. We can also pull the code down locally, edit it, and then push it back up when we want to. Right now, since I'm developing and I'm playing around, I'm going to edit my code in the browser. If I was doing something production-wise, and I was going to actually start deploying this, maybe set up continuous integration, stuff like that, I'd want to get that code down and actually edit it locally, and maybe run it and deploy it, or rather, run it and debug it locally, which you can do before you push it up to the server. Now, if you've chosen the .NET backend, this basically creates a web API-based ASP.NET application. You develop this in Visual Studio, you run and debug it locally just like you can with a Node.js one, and then when you're done, you deploy that to Azure. Now, it doesn't use dynamic schematization, but it does use something called code first, which basically lets you create the database schema in your code, as opposed to, again, having to be a DBA and going in to create your SQL and stuff like that. There's also an easy way to connect to other storage systems like Azure Table Storage and things like that. Now, so far, when we connect to that to-do item table, it's basically a REST API around the table. Everything is tied into that table. But if I just wanted to create endpoints and define whatever functionality I want, we can create custom APIs where we can define whatever functionality we want for all the HTTP methods, and expose that, and we have really easy ways to connect to that via the client SDK. So let's go ahead and look at doing some of this stuff. So the first thing I'm going to do is go back to my mobile application, and I'll go to my to-do item table here. I'm going to open that back up. And we'll refresh this to make sure the data's there. Good. And now we're going to hit this edit script button. Now, inside here, basically, it's going to open a web-based editor for all of the code running my web application. Give it a second to run, and while it does that, I'm going to go ahead and copy some code so we don't have to watch me type for a long time. So over here on the left side, let's increase the size of this. So over here on the left side, you see we get all these files. If you're familiar with Node.js, you see the app.js here where I'm defining some functionality. What's interesting about this is because we are running an IIS, we still have a web.config file which explains what's running and the node is running. So what we're going to look at first though is this tables folder here. Inside here we've got two files. We've got to-do item.js and to-do item.json. The JSON file here contains permission stuff that we're going to get into when we talk about authentication. The to-do item.js though, this is where the functionality for my table API is, right? So inside here, essentially right now, I don't really have very much code, but I do have all these commented out methods. Essentially right now, it's just using the default of whatever request I get against the to-do item table, it's going to pass it through the server, so I convert that into SQL and run it. But I can uncomment this and insert my own functionality. So let's say I want to do some data validation when I create data, when I insert a to item. Let's say I want to check the length of the actual text to make sure it's not too short. So in this case, if the text that I pass in is less than 3 characters, I'm going to append this and this on there. Now in reality, I might want to send back some data validation to the client application. That's up to me as a developer to decide how I want to handle this scenario. So let's go back to our application here. And one thing you'll notice is whenever I make a change to the back end, the very next request takes a little bit longer because it has to reload the site. You only see this once, but you'll see it every time I actually make a change. That's again a reason why if you were in production, you might not want to go in here and just manually change the file every time you want to. So let's just say AB, and we'll save that. And now if we refresh it, it's going up to the server, it's going to this insert method, it's getting checked and says that data is too short, so it appends that text, it puts that in the database, and then it replies back and says, hey, here's the updated item. So now I can see that my updated item has that text on top of it. So really easily I can do my own logic, and you can get as creative as you want in here. This is very, very simple. The next thing we'll look at is creating an easy API. So inside here, we'll go to easy APIs. We don't have any right now, so we'll just create one. So I'm going to call this mark all to-dos. And essentially what I'm going to do is I'm going to create an endpoint that I can call to update all of my to-do items with either complete or incomplete. So we're going to skip back past the permissions for now. We'll look at it later, I promise. We'll wait for the API to get created. And while it does that, we'll go ahead and copy some more code. All right, so the API was created, so I'm going to go back into my editor. I'm going to open the API folder now. You'll see now I have this mark all to do's JS and JSON file. I'm going to go ahead and overwrite this. And essentially what I'm doing is I'm exporting this functionality for this get method. Inside the get method, I create a SQL query and just say, hey, update all the to-do items, and set the complete equal to whatever the completed variable I pass in as a query string parameter is. So I execute that, and then I return all of the results. So that's saved on the server, so now I can call on this API. I just need to change the client side to actually do that. So let's go back to our application, and we're going to go in here, and again, we will copy a little bit of code. So first thing we're going to do is I'm going to add a class to make accessing our mobile app client a little bit easier. So all I've done here is I've said, this is the same exact code we had in the table view controller. I'm just putting it here so I've got a same place I can access this client from all of my from everywhere else in my application. So inside here, I'll go back up to the viewDidLoad method, and I'm just going to go ahead and comment this out, and I'll say let client equal client manager. There we go. Shared client. And the next step is I need to actually add the code to call into my my API. So we'll copy this and then we'll walk through it. So inside here, we get that shared client, and then we call invoke API on it. We're calling the mark all to do's method. I'm not passing anybody in. I'm just calling the get method. But I am passing the completed parameter as true. So basically, when I call this code, I want it to mark all of my to do items complete. The last part is just to add something on my UI so I can actually trigger this. All right, so let's go ahead and run our application again. And again, I made a change to the back end, so the first request is a little bit slower. All right, great. So now we'll hit finish. Now, as part of that finish, it triggered a refresh when I was done. But as we see, if I try to refresh again, I don't have any data. And if I go back to my tables here, so all the items have been marked complete. We don't have any data to show. So really easy to create, or to rather modify what happens when you call your table API, and then also create other functionality inside those custom APIs. So the next thing we're going to talk about is push notifications. So if you're not aware of push notifications, you've never implemented it before, really quickly we'll walk through how it works. Essentially, your client application, so our Swift application, says to APNS, I want to get push notifications. APNS then says, okay, here's a token, and it identifies this application and this device to APNS. To me, it's just a string of gibberish. It means nothing to me, but APNS thinks it's important, or knows it's important. From there, from whatever backend I have, I can basically say to APNS, hey APNS, here's the token, here's some data I want you to send, deliver this down to the device. And if APNS says everything is good with my data, it will then push that down to my device. And depending on what the code is in my application, maybe I'll show a toast, maybe I'll make a sound, maybe it adds a badge. It's up to me. Now, in this scenario, though, we have to have somewhere where we're tracking those tokens. And more so, if we want to have some way of pushing to maybe a specific user or a group of users, we need to understand what that token ties into. So, what token is Chris's iPhone? What token is Chris's iPad? What token does everyone in Denver have? So that's something that we need to track. So Azure has a service called Notification Hub that deals with that for you. So essentially the flow here is your client application still goes to APNS and says, hey, I need a token. That token is then sent up to your Notification Hub, and you can include a list of tags that are then associated with that token. So a tag could be something like your username, or maybe your zip code, or the sports team you like, or anything you want to do. Well, the Notification Hub will handle storing that token as well as any tags you want, in addition to templates that allow you to specify how data should be sent to your device. Then whenever you want to trigger a push notification, you say to your hub, a Notification Hub, send this data to this tag, or just to everyone, or to all iOS devices. It's up to you to kind of decide how you want that. And Notification Hubs will deal with scaling out to make sure that those push notifications are delivered in a timely manner, as well as handle any issues with APNS. So the funny thing about APNS is that it doesn't actually give you a response right away that says, hey, this was success, or this token is bad, and like that. You have to actually actively call into a separate API every once in a while from APNS to say, are there any updates I should know about? Notification Hubs will deal with getting those updates, and then if it finds that a token is invalid, it'll remove that for you. So there's a bunch of advantages of using Notification Hubs. It works with any platform on the server side, the client side. Everything is exposed from Notification Hubs via REST API. So while I'm going to be calling it from Node, which we have code to do for it, if you were building something in a language we didn't have an SDK for, it's all REST API. It's very easy to talk to. And the client side supports iOS, Android, Windows, Baidu, Kindle, all the primary platforms you want to build for. So you don't have to deal with storing all that device information or tag-based stuff, or groups or anything like that. You get personalization as well as localization. So you have the ability to specify languages, things that should go in, what format data should go in, all sorts of good stuff. Like I mentioned, it scales out, so you can deliver millions of push notifications without having to worry about how it works behind the scenes or how it runs. And you get, of course, telemetry to show you how it works as well. So let's go ahead and implement push notifications. So the first thing I'm going to do is I'm actually going to run my application on a different device so we can actually see push notifications in action. There we go. Perfect. Okay, so the first thing we're going to do is we're going to go into the portal, and I'm going to go down to push, because what I need to do is I need to get my notification hub, the certificate I got from the iOS developer portal. Now I already set up a notification hub. If I hadn't, I'd go in here and I'd basically say create a notification hub named this. It's really a 20-second thing, but I already did that to save a little bit of time. So I'm going to go in here and I'm going to upload my certificate. And I'll choose this one. And like every good developer, I didn't leave a password on it, so I can go ahead and save that. So essentially, it's taking the certificate and giving it my notification hub, so now when I tell my notification hub, hey, whenever I want you to push the APNS, it has a certificate to use. So the next step is we need to change both the server side and the client side. So let's go ahead and do a little bit more code. Actually, we'll do the client side first. So the first thing I'm going to do is I'm going to change the bundle identifier just to match the one that I already generated for that certificate, just because I have to do that. It has to be done. Then I'm going to change the provisioning profiles and the code signing identities to be the right one. If it works. There we go. All right, so that still builds. That's fine, great. So now we're going to go and finish setting up our client-side code. So everything we add is just going to be in the app delegate class. So we'll go to the app delegate. First thing we do is replace the application did finish loading. And basically inside here we call register user notification settings. We're just saying, hey, we want to get alerts, badges, and sounds. And then we call register. This is where we go up to APNS and say, APNS, I want to get a token. Then we add a few callback methods. Now the first callback is it did register for remote notifications with device token. This is the method that gets called back in my application when I hear back from APNS. Inside here, I get this device token, which is right here. Once I get that, I get my shared client object. So again, this is my mobile application client, and I call that push, and then I say register device token. So this is what says to my notification hub, hey, here's a token. Now right now I'm not passing up any additional tags or tying this into usernames and stuff like that, but this would be where I would do that. I've got a method to handle if I fail to register for remote notifications. And then down here, I've got a method that this is called whenever I get a push notification. And in this case, all I'm doing is I'm just popping up a UI alert with the data that was sent over as part of the push notification. So from a client side, that's all I need to do. The last bit is I need to change the server side. So I'm going to go back into my to-do item, and I'm just going to change my to-do items insert method so that whenever I receive a new to-do item, I'm going to send a push notification. So I'm just adding a few new requirements up here, and then I'm going to replace the insert method. So basically in here, what we see here is I'm creating a payload with the text of the to-do item. I'm then basically calling context to execute. So insert the to-do item, and then when you get a success back, call push.h.apns.send, and then I'm passing in the payload. If I wanted to specify a specific tag, so push to Chris's iPhone or push to all of Chris's devices, this is where I'd specify it right there. So now the next step is I just need to run my application. Get back into this. Okay, so we're going to go ahead and change this to my iPhone, and we'll go ahead and run this. Restart this application. Oh, that's fun. All right, so what we have here is we've got both my device I've got up here on the left side and then the simulator on the right side. So let's go ahead and just say test. And what we should see after I save this and sync it up the server is I should see a UI alert be pop up because I'll get a push notification. So go ahead and save that, and we'll sync. All right, there you go. So Wi-Fi's slow. So I get that push notification, and remember, this is going to get pushed no matter who saves the to item at this point, and it's going to push to everyone with an iOS device. So if I go in here, and I say test again, can save that, and when we refresh, we should see we'll get another push notification over here. Great. So my push notifications are working really easy, and now on the server side, I can dictate whenever I want to do a push, and it's really easy. All I need is that push.apns, and then I can specify tags, payload, all that good stuff. All right, so we're going to try and breeze through authentication because we don't have too much time. So when it comes to authentication, there's two ways to do it. There's a server flow and a client flow. The server flow is basically using a web view to do OAuth. We've all done this. We've all signed in using this. If you've actually had to write it yourself, it's kind of a pain. It's all part of the SDK for you, and again, you get Google, Facebook, Twitter, Microsoft account authentication, as well as the Azure Active Directory. When you're doing the server side, you pop open a web view, the user authenticates. It hands the authentication information back to the mobile app, which then gives your client application an identity, and then you pass that identity automatically whenever you make additional requests. The client-side flow is if you're using the native SDK, so for example, the Facebook and Twitter SDKs that are built into iOS, you can authenticate using those. Your application gets the auth code and token back. You then pass that up to your mobile app, which verifies it's correct, and then you get an identity back. At the end of the day, you're left with the same result where you have an identity object which on every request to your mobile app identifies as you as a user. And once you are authenticated, you get some interesting information back. So right now, all of our requests are just anonymous. Once you're authenticated, though, you actually have an ID that corresponds with whatever authentication system you use, and then you're able to get access to that provider's graph. So if you need to access the Facebook graph, for example, when your users authenticate with Facebook, you can do that. You also get basic information, so stuff like your name, your profile picture URL, your locale, things like that. So let's go ahead and try to quickly add authentication. So I'm going to go ahead and go back over here, and I'm going to go up to the authentication and authorization area. Yep, that's fine. And then in this page over here, I'm going to create a new application in Twitter. I'm just going to add Twitter authentication. So we'll call this 360 IDEV. And then I'm going to go ahead and grab the URL for my application actually really quickly. Go back over here and paste that in. Now I always have to check because you have to actually add a little bit onto the callback URL for your authentication. There we go. So basically you just have to add .auth/login/Twitter/callback there so it knows what endpoint in your mobile app to talk to. We'll go ahead and create our Twitter application over there. We'll go back here. And I'm going to turn on app service authentication. I'm going to tell it by default I just want to use Twitter. And then I'm going to go ahead and configure Twitter. Now you don't have to choose one of these. You could implement all of these and give your users the option of how they want to authenticate if you'd like to. Oops. And we'll save that. And save. All right, now if I go back to my object here, and we'll go to Easy Tables. And it's going to load eventually. While that's waiting, we'll just go ahead and make the changes to the client side. So our changes to the client side are really simple. All we have to do is basically tell it when to authenticate and how. So I'm going to add this method in here called login and get data. Inside here we're calling client.login with provider and specifying that we want to log in with Twitter. This is going to handle all that web view stuff, all the OAuth. It's going to handle all of that for us. So then down in the view did load. I'll get rid of this code to refresh automatically, and I'll just say login and get data. So we'll do that. Let's go back here to the portal. Okay. So now we're going to go ahead and change permissions. We're going to say authenticated access only. So now we have to have a valid user tied to this application in order for us to make any requests against the to-do table. You can do the same thing with all your APIs. You can mix authentication schemes however you want to do it. So now if I go back here and I say test again, what we should see if hold on, let me redo this on my success. So the first thing it's doing is popping open a login screen because I need to authenticate. So I'll use a Twitter account I don't really use, and we'll hide that so nobody has to see the password. Great, it's going to redirect me back to the application, and now I'm in, and I can go ahead and refresh data if I want to. but I changed the backend, so it's going to take a few seconds. So now I see the data. Now, what I really want to do, though, is I really want to actually restrict what data people see. So really quickly, we'll walk through how you do that. I'll just go back to the toItem.js. So now if I want to tie items that I save to my user, I could do that on the client side, but you never really want to trust data from the client. Whereas once a request gets to this point, I know that the user, the identity object, the user object that gets set up with the request, I know it's valid because of the mobile application has checked it for me. So in the insert method, what I can do is I can basically take the to-do item before it gets inserted and add a user ID to it and just specify that it's the user ID of the user gets in. So now when I save data, it's going to be tied to my user ID. And then likewise, if I want to restrict access data that I can see, when I actually read data, I can add a query to the clause that I'm getting. So whatever the predicate I created, which is where the to-do items are not completed, I'm adding one here. I'm saying where the user ID is equal to the user that's coming in. So really easy to add authentication and then also control who and how you access data. So since we're super short on time, I'm going to go ahead and skip past showing the rest of that part and just kind of talk through some more services. So some of the stuff I didn't have a chance to show you guys today, but are features of app service and mobile applications. Stuff like scaling. So if you remember early on when I went through the process of creating a mobile app, you can choose what size VM you want running your application behind the scenes. And that's something you can change whenever you want. So let's say right today I'm in development, so I just choose free because I don't want to pay for developing. And then later on, hey, my application's kind of popular. I actually want to pay for it. I want to have a big VM running it. Well, all you do is you go into the app service setting and say, instead of this size VM, I want to run that size. In addition to being able to change kind of the size of the VM that's actually running it, you're also able to scale out the number of machines running it. And you can set up auto scaling. So for example, you can say, hey, if performance is, if I'm really getting hit a lot, spin up multiple instances of my application. But if I'm not getting hit very much at all, spin them down. At the end of the day, it's about saving you as much money and time as possible. You also get stuff like traffic routing, which enables you to do A/B testing. Send 10% of my traffic to this site, send 90% to this site, stuff like that. Site select is really awesome because it enables you to set up more than one kind of version of your mobile app backend. So you could have a production version and a staging version and a test version, and however many versions you want. And what that enables you to do is you can push all your changes to one version of that, test it out, and essentially swap those changes into the next environment. So push everything to testing, test it out, and then swap into production. Backup and restore, you automatically get that on both the files that are in your mobile app as well as the database. So it's automatically going to restore or back up for a period of, I think, free is up to a week, and then you can restore it anytime you want. And then as I mentioned before, on top of being able to edit the code in the portal, I can also pull that code down, create a Git repository for it within our mobile app, and then use that as source control as well. Or to push out from something like another source control system if you want to. So really quick, I want to talk about some other features for, we have enough time. Yeah, we got 2 minutes. So mobile app continuous delivery. So this is actually multiple features that enable you to build really great applications, whether you're doing iOS, Android, anything else, it all works. So essentially, there's the ability to have a code repository, build and deploy your applications, running continuous integration, so running your tests as well, automated UI testing, beta testing, and then telemetry. So on the code repository side, there's something called Visual Studio Team Services. The naming is terrible because it has nothing to do with Visual Studio. But essentially what this is it's a code repository, whether you're using Git or Team Foundation version control. Project management, so if you're used to doing Agile, you can use Kanban, work items, bugs, task tracking, iterations, all that stuff is in there. As well as a build system. So in this case, we can set up to build our iOS apps whenever we check in code or whenever we want to trigger a build, whether that's nightly or something like that. So that will build out your iOS app, run all the unit tests for you. And then from there, you can also send your application up to Xamarin Test Cloud, which, despite the fact that it is Xamarin, will run native, will run Cordova, will run PhoneGap, will run any sort of application you build. And you can basically create automated UI tests to run through your application on whatever devices you want. They've got I think over 2,000 different devices of the iOS and Android variety. But this is really cool because if you don't have every single device that you want to test against, they probably do. And you get really cool graphic flows of what happens when your application is tested. You can make sure everything looks good on the different size devices. It's really very handy. And it gives you really great reports out about what device did things fail on, what were the details of the test log. It's really good stuff. And then, if you're familiar with Pacquiao, there's plugins for Visual Studio Team Services as well as Jenkins and all those. to help you deploy your application for beta testing via Pacquiao. And this is really handy. It gives you crash reporting and user feedback, all sorts of good stuff. Really quickly, cognitive services is a slew of features from Microsoft that give you the ability to kind of put some really awesome functionality into your iOS applications. So you can do stuff like image recognition, like send up an image and say what's in this image, detect the faces in this, give the emotion detection of the person in this picture smiling or sad, etc. There's also stuff like video recognition, speech recognition, language understanding, etc. So a few links for everyone. If you go to aka.ms/zoomo, the documentation there will basically guide you through everything I did today as far as doing data storage, doing user authentication, doing push notifications. If you're going to try out service.azure.com, you can actually spin up a mobile application backend for, it only lasts for an hour, but you need nothing more than an account, like a Microsoft account to sign in. You don't have to sign up for Azure to try it out or anything like that. You just create it. VisualStudio.com is where you sign up for VSTS. Testcloud.xamarin.com is where you see that test cloud stuff, and then Pacquiao.net. Feel free to reach out to me at any time. I'm already a minute over, so I appreciate everybody coming out to watch. If anybody has any questions, I'd love to answer them. Well, come up and see me afterwards. All right. Thanks, everybody. Appreciate your time.